So we have batteries. Where do people use batteries? Okay, the applications are very common and we come across them on a daily basis. Batteries can be used as power sources, a source of electricity for electronics, mobile electronics, automobiles, and many more. Okay, here we showed batteries, the common AA battery, um, AAA battery, and type D battery, type C battery, and this 9-volt battery. And this is a photo for a cell phone battery and it's opened. And for mobile purpose or for small like toys and many other stuff. This is the automobile or car battery. Of course, battery can be also used like backup power for computer servers, for emergency lighting. They all use battery, and it can also be used for energy storage, for renewable energy. For example, we have a wind turbine, and then if you want to use the electricity when there's no wind, you can power them with large batteries. Okay, and there are many other applications for batteries. And we can classify batteries by whether they can be recharged or not, also called recharge capability. Those that cannot be recharged are called primary battery. Primary battery, you use it once, no recharging. Many alkaline battery are typically not rechargeable. Zinc manganese oxide battery are not rechargeable. Okay, but there are also secondary or so-called rechargeable batteries. For your automobile, lead acid battery, okay, chargeable. Nickel cadmium, nickel metal hydride. These earlier days for camcorder, for cassette player, mobile cassette player, they quite often use these types of battery, but later they all moved towards lithium ion battery like this. Okay, these are called secondary or rechargeable battery. Primary battery like these tip are now cannot be recharged. Alkaline battery. Secondary battery, lead acid battery, lithium ion battery, and many more are rechargeable. Okay, which means you can go back and forth from chemical energy to electricity, and then from electricity back to chemical energy to reuse them. That's called secondary battery or rechargeable battery. Apart from primary and secondary batteries, there are other ways to classify batteries, especially by chemistry. And when we classify battery by chemistry, there are essentially infinite possibilities when you look at the electrode potential theory and do combination. There are many possibilities. Here we show lead acid battery. Okay, we'll talk about it in a moment. They're quite often used for automobile applications. We have alkaline batteries, zinc and manganese oxide, essentially battery. We have silver zinc battery, zinc and silver oxide, essentially battery. We have zinc air battery. In here, the positive electrode would be air, and we have nickel cadmium battery, and this one early days for mobile device. You see this nickel cadmium, and it's a so-called secondary or rechargeable battery. Nickel metal hydride battery, nickel metal hydride battery, also another secondary or rechargeable battery. Finally, lithium ion battery, rechargeable battery, and there are many more possibilities. Okay, and there are other battery chemistries such as sodium sulfur batteries, lithium sulfur batteries. There may be lithium oxygen apart from zinc there may be lithium ion batteries. Of course, many of these are still in development stage. And apart from basic chemistry, we can also classify batteries based on the mechanism of the electrode reaction. Most of them belong to the so-called conversion or reconstruction type of electrode or battery. And these include lead acid battery, alkaline battery, and the nickel cadmium battery, nickel metal hydride battery, going from one material to a completely different material. Okay, conversion or reconstruction battery. During the conversion process, quite often there will be significant structure reconstruction at atomic level and even at a micro scale level. On the other hand, there would be so-called insertion type or rocking chair battery, and the good example would be LIB, lithium-ion battery. Okay, we'll talk about this in a moment. What are the requirements for batteries? Of course, we need fast electrode reactions, which means we don't have to spend too much energy or over potential for electrode reactions. Our efficiency would be high. Um, on the other hand, we want, practically speaking, equilibrium cell potential greater than 1 volt with working potential greater than around 0.5 volt. Okay? So that's ideal. You don't want a battery that only gives you tiny bit of voltage. We want stability with little self-discharging or with no unwanted reactions. With environmental typical packaging, high power and high energy density. Of course, ideally you want the highest power density or energy density as possible, and low cost. Of course, you don't want it to pay too much for the battery. There are many more requirements, but on the other hand, bear in mind, any single battery or most cases excel in certain aspects but lacks in other. For example, lithium-ion battery is good electrode reaction, good potential, reasonable stability, but the power density not super high, and the cost wise is also not very good and not super low. You can cite the same examples for many other batteries. That's why there's not a single battery that replaces every other battery. Many battery have their niche application field or niche market that it uniquely meets all the requirement. Okay.